Welcome to Digital Toolbox. Today we'll go over how to find the normal to any surface. And you guys should have a surface lofted in Rhino or Grasshopper. And then once you guys finish that, we'll go to Surface, go Analysis, and grab the Evaluate Surface button. It's asking for a surface to evaluate, so we'll bring our lofted surface and connect it there. And then a UV point, so we'll go to Vector and grab a point XYZ. And then connect to UV. The X, Y, and Z is all default at 0, so that's why it's starting at the corner of a surface. And if we grab some number sliders and plug this into X and Y, since that's the U and V, and we toggle X to 1, you can see that it moved to 1 foot. To make the U and V as a unit of 1, we'll right click on S in the Evaluate Surface button and click on Reparameterize. This will make the U and V as a unit of 1, so now we can toggle our sliders and the point on our surface will move accordingly. Next thing we need to do is create the line from this point that's normal to the surface. So to do that, we'll go to Vector, Vector, and then Multiply. And then it's asking for a vector, so that's going to be our normal. If you hover over N, it says normal at UV, so that'll go into V. And then F is the length of our line. So we'll go to parameters and grab a number slider. I'm going to add this to integers. And the lower limit of, I'm going to put -48, upper limit of 48, and the value to be 24. And then I'm going to convert this into inches. So I'll go to logic and grab the one variable expression. And into expression editor, I'll type in x over 12. And then connect all this. Then we need to sum up the vectors, this point here and the vector here. So to do that, we'll go back into vector, vector, and click on summation. So we'll plug in A into the vector, and then the point into B, and it'll give us a vector that is eventually will be our line. So we'll go to curve, go to primitive, and go to line. And we'll connect the new point, which is our vector, and the old point. It'll give us a line that is normal to the surface. And I'm just going to pipe this line so that you guys can see it more clearly. And I'm going to grab a number slider so I can make this pipe radius smaller. I'm going to unpreview this line, unpreview the evaluate. I'm going to crank this up to 48. So now you guys can see the pipe normal to any spot on the surface. Also, if we make this negative, now the pipe is under the surface and is still normal. To find the exact center of any surface, that means if everything is a unit of 1, that means 0.5 of the U and the V direction will give us the exact center. So I'm going to right click here and type in 0.5, and right click here and type in 0.5. This will give us the exact center of any surface that we're evaluating and the normal to that point. This will come in handy later when we do definitions for space frames or panelizing surface, when we do need to find the center of a surface and the normal vector to it. And another way to get 0.5 is to simply go to logic and grab a two variable expression and take the expression as x over y. And I'm going to take this number slider here and I'm going to crank this up to a fully 1. And then this slider, I'm going to change this to a value of 2 and lower a limit of 0. Now I'm going to plug that into y, and this will give us 0.5. And now I can just plug that into x and y. And that will give us the exact center of any surface and the normal to it. So that's how you find the normal. And I also like to give out a shout out to Andrew Cudless, because he came to Cal Poly and he's the one that showed us how to figure out the normal to any surface. And thank you for watching.